Bismillahirrahmanirrahim. My dear students, here is your mathematics teacher Muhammad Al Said from Pakistan International School, Taif. Today we will continue our lecture number 73, exercise 8.2. Last time we finished our question number 8. Now we have question number 9. Find the term independent of x. Find the term independent of x. In case of the term independent of x, it means that in your answer you will have x power 0. You will have x power 0. Here we can have term independent of x. There are two parts, part number 1 and 3. Now I am going to choose part number 3. Question number 10, part 3. Rather, this is question number 9, not 10. Question number 9, part 3. Term independent of x. You have to find term independent of x. 1 plus x square whole cube, 1 plus x square whole cube into we have 1 plus 1 over x square whole power 4. 1 plus 1 over x square whole power 4. Dear students, you can have 1 plus x square whole power 3. You take x square LCM. Here it will be x square plus 1 whole power 4. You can have 1 plus x square power 3. This will be 1 plus x square power 4. X square whole power 4. Distribute this power to 1 plus x square and x square. But in this way you can have 1 plus x square whole power 7. 3 plus 4. Here is x8. So we have you can check 1 plus x square, x power 8 over 7 into 7. We can divide by 7 and multiply by 7. Why we are dividing and multiplying? Because I want to insert this term inside this bracket. I have to write down this term inside the bracket. So here is 1 plus x square over x 8 over 7 whole power 7. That will be 1 over x power 8 over 7 plus x square over x 8 over 7 whole power 7. Dear students, now we can have 1 over x 8 over 7 plus x2 minus 8 over 7 whole 7. Bring this x power 8 over 7 up and subtract from x square. So we will have 1 over x 8 over 7 plus 14 minus 8. 7 to the 14. This is x 6 over 7 power 7. So you can write down x 6 over 7 plus 1 over x 8 over 7 whole power 7. Yes, we have now a is equal to x 6 over 7, b is equal to x power minus 8 over 7 and n is equal to 7 are to be find out. Bring this x power 8 over 7 up, it will be x power minus 8 over 7. So using TR plus 1 NCRAN minus RPR. TR plus 1 N is 7CR x power 6 over 7 whole power 7 minus R into B is x power minus 8 over 7 whole power R. TR plus 1 7CR x power 6 over 7 multiplied by 7, 7 cancelled out, 6 minus 6 over 7R. This is multiplied by 7 cancelled out, we left with 6. Now 6 over 7 is multiplied by R minus 6 over 7R. Here is x power minus 8 over 7R. TR plus 1 7CR x minus 6 over 7R minus 8 over 7R. This will be 8 and 6, 14 minus 14 over 7, that is minus 2R. 7CR x power 6 minus 2R TR plus 1. Term independent of x means term involving x0. Term independent of x means term involving x0 because x0 is 1. So we can have in this way, we can write down to get required term, let 6 minus 2R is equal to 0, 6 is equal to 2R and R is equal to 3. Using R is equal to 3 here. So therefore, T3 plus 1 is equal to 7C3 x power 6 minus 2 into 3. T4 and 7C3 is 35. You know that this is 7 factorial over 3 factorial into 7 minus 3 factorial and x6 minus 6. 7 factorial over 3 factorial into 4 factorial x power 0. T4 is 7 into 6 into 5 into 4 factorial over 3 factorial 4 factorial x power 0 mean 1. 4 factorial cancelled out. 3 factorial can be written as 3 into 2 into 1. 3 to the 6 cancelled. 7 5 the 35. So dear students, this is the term independent of x mean here is x0 involved. Your answer is 35. I hope that you understood this question. After that, we have question number 10, 11. These questions are similar. I am taking question number 11. We have to find the middle term. For example, in question number 10, in middle term, the power is 12. So dear students, if the power is an odd number, then you will have one central value as middle term. For example, in part number 1, power n is 12. So how many total number of terms there? 12 plus 1 because first term always starts from 7C0, for example. 7C0, 7C1, like that. So there are 30 terms, 13 terms. So 6th term before, 6th term after, 7th term will be your middle term for your part number 1. So in this way you can find your middle term. Question number 11. Find 2n plus 1th term from the end of this expansion. 2n plus 1th term from the end of your expansion. So here is 2n plus 1th term from the end in the expansion of. Yes, total number of terms, the power is 3n. So what is the total number of terms? 3n plus 1. Here is, we will have question number 11. Question number 11. So we can have question number 11. With the help of lesson number 11, you can understand the other parts. For example, find the 2n plus 1th term from the end in the expansion. Find 2n plus 1 from the end of the expansion. X minus 1 over 2x whole power 3n. Dear students, you can check what is the total number of terms. N is equal to 3n, A is equal to x, B is equal to minus 1 over 2x. Total number of terms. Total number of terms is equal to 3n plus 1. And the question is, find 2n plus 1 from the end of this. So what is 2n plus 1 from the end? We can have 3n plus 1 required term minus 2n. So here is n plus 1. N plus 1 term from the beginning. This is n plus 1 term from the beginning. N plus 1 term. So what is R from here? R is actually n. R is actually n. Therefore, T R plus 1 N C R A N minus R B R. You can apply the values. T n plus 1 is equal to 3n C n, A 3n minus n, B is minus 1 over 2x power n. Here we can have 3n factorial over n factorial into 3n minus n factorial. A power 2n minus 1 power n into 1 over 2 power n x power n. So dear students, we will have 3n factorial over n factorial into 2n factorial. Yes, we will have minus 1 power n over 2 power n into 1 over x power n. 1 over x power n. So this is your required 2n plus 1 from the end of this expression. So required term was n plus 1 because this is the remaining terms. In case of remaining term, Tn plus 1 mean r is equal to n, then we will get Tn plus 1. Tn plus 1 term. So in this way, dear students, we have finished our question. After that, we have question number 12, 13 and 14. I am taking question number 12. Question number 12. Question number 12. Show that the middle term of 1 plus x power 2n is 12. Show that the middle term of 1 plus x power n, 1 plus x power 2n is 1, 3, 5, 7 up to so on 2n minus 1 over n factorial into 2 power n xn, 2 power n xn. Dear students, you can check. So we have as n is equal to 2n, this is even number. So total terms, what will be total terms? 2n plus 1. This is even. If you add 1, this will become odd. So what is middle term? Middle term formula is 2n plus 1 plus 1 over 2th. 2n plus 1. For example, it was 7. So 7 plus 1 over 2. 8 over 2. That is fourth term will be the middle term in case of 7. So here is 2n plus 1 plus 1 over 2, 2n plus 2 over 2, 2 common n plus 1 over 2 cancelled, n plus 1th. This is, we have middle term as n plus 1th term. So from here you can check a is equal to 1, b is equal to x, n is equal to 2n, r is equal to n. Using tr plus 1 is equal to ncr, an minus rbr. T n plus 1 is equal to 2ncn, a is 1, 2n minus n, b is x power n. Tn plus 1 is equal to 2n n factorial over n factorial into 2n minus n factorial, 1 power n and x power n. Here is, yes, we can write down as 2n factorial over n factorial into n factorial and xn power n. If we open up this 2n factorial, it will be 2n into 2n minus 1, 2n minus 2, 2n minus 3, 2n minus 4, up to so on 6, 5, 4, 3, 2 and 1, whole divided by n factorial. Here is x power n. We have opened 2n factorial as 2n into 2n minus 1, 2n minus 2 like this. After that, dear students, we can have this is our required term, this is required answer. Now I am having 2n into 2n minus 1, taking 2 common from here, 2 into n minus 1, 2n minus 3, 2 common from here, 2 into n minus 2, up to so on. This will be 6, 5, 4, 3, 2 and 1, whole divided by n factorial, and here is x power n. So dear students, you can check, this is 2, 2, this is 2, from here we have 2, from here we have 2, from all these terms n times we have 2. So that will be 2 power n, and we are left with n into 2n minus 1 into n minus 1, 2n minus 3 into n minus 2, up to so on. That will be 3, or rather this will be 5, 3 and 1. This is xn and whole over n factorial. Actually this was n factorial into n factorial. That was 2 times. Yes, it is true. After this, dear students, you can check 2 power n into n minus 1 into n minus 2 into up to so on. We have n into n minus 1, n minus 2, n minus 3 up to so on. We will have n factorial. And what is left? 1, 3, 5 up to so on 2n minus 3, 2n minus 1 like that. Here is 1, 3, 5, 2n minus 3, 2n minus 1 over n factorial. Here is power xn and n factorial second time also. So n factorial cancelled out. We have 1, 3, 5 up to so on 2n minus 1. This is 2 power n. This is x power n, and over was n factorial. That is your answer. After that, we can have question number, out of 13 and 14, we can take question number 13. In case of question number 13, we are given show that NC1 plus NC3 plus NC5 plus so on, NCn minus 1 is equal to 2 power n minus 1. Question number 13. Show that NC1, NC3, NC5, NC7 plus so on to NCn minus 1, that will be equal to 2 power n minus 1. 2 power n minus 1. We know that 1 plus x power n is equal to nc0 1 power n x0, nc1 1 power n minus 1 x1, nc2 1 power n minus 2 x squared, nc3 1 power n minus 3 x cube, plus nc4 1 power n minus 4 x4, nc5 1 power n minus 5 x5. Here is nc6 1 power n minus 6 x6 plus so on. Dear students, this is basically the binomial series. This is opening of binomial series. Let x is equal to 1. In all you will put x is equal to 1. So 1 plus 1 power n is equal to nc0. 1 power n is 1 and x power x1 is 1 power 0 is 1 again. Then nc1 1 power anything power 1 is 1 and x is 1. So nc2 plus nc3 plus nc4 nc5 plus nc6 plus so on. Dear students, here is this is 2 power n, that is sum of all coefficients, sum of all coefficients, sum of all coefficients, this is 2 power n. If x is equal to minus 1, if we apply x is equal to minus 1, so what will be, you can check, this is 0, 1 minus 1 is 0 power n is 0. 0 is equal to nc0, this is 1, this is 1 also. But here is x is equal to minus 1, you will have minus nc1. Here is x square. Because of x square minus 1 whole square, it will become plus nc2. Then here is x cube. Minus 1 power 3. The minus will remain as it is, it will come here. It will be minus nc3. Then plus nc4. Minus nc5. Plus nc6. Plus so on. Dear students, now you can have minus nc1, minus nc3, minus nc5 to the left hand side. Bring it. nc1 plus nc3 plus nc5 plus so on is equal to nc0 plus nc2 plus nc4 plus so on. So dear students, you can check in the expansion of binomial series, sum of odd coefficients is equal to sum of even coefficients. This is sum of odd equal to sum of even coefficients. So here we can have yes, sum of odd coefficient equal to sum of even coefficient. So sum of all coefficient was 2 power n. If we take sum of odd coefficient, it will be half of all. If we take sum of even coefficient, it will be half of all coefficients. Therefore, sum of odd coefficients, what was sum of all coefficients? Is equal to half of sum of all coefficients. Sum of odd coefficient was NC1, NC3, NC5 plus so on. What was sum of all coefficients? Sum of all coefficient was 2 power n. Here is 2 power n. Bring this 2 up, it will be 2 power minus 1. So 2 power n minus 1, that was your right hand side of this question. Yes, we have question number 13. So with this question, I hope that you can do other parts. And now we are going to move our exercise 8.3. In exercise 8.3, we will apply a binomial series. We will apply a binomial series. Exercise 8.3, binomial series is 1 plus x power n, 1 plus nx plus n into n minus 1 over 1 into 2 or 2 factorial x square, n into n minus 1 and minus 2 over 1, 2, 3 or 3 factorial, that is same thing. X cube plus so on. This is known as binomial series. In our exercise 8.3, we will make use of binomial series. Dear students, we are given question number 1 part number 3 and part number 5, part number 7 and 8. I am taking part number 5. I am taking part number 5. If you understand this part number 5, you can easily understand your part number 3 even. So we will have and expand the following up to 4 terms, taking the value of x such that the expansion is valid. 8 minus 2x power minus 1. 8 minus 2x power minus 1. Dear students, first of all, convert this binomial into the proper binomial series. In proper binomial series, you have 1 in the center. In the first place, take 8 common. Here you can have 8 common, that will be 1. 8 divided by 8 is 1. 2x divided by 8 is this. Whole power minus 1. So 8 power minus 1. 1 minus x over 4 minus 1. So 8 power minus 1 can be written as 1 over 8. And dear students, we have to open up to the fourth term. 1 plus n x. This is n, this is x. 1 plus n x. Plus n into n minus 1. Yes. Over 1 into 2. X square. Plus n into n minus 1 and minus 2 over 1, 2, 3 minus x over 4 cube plus so on. So dear students, 1, 2, 3 and 4 terms. Up to 4 terms it was the question. We have to write down up to 4 terms. 1 plus x over 4 plus minus 1 into minus 2 over 2. Here is x square over 16. Then minus 1, minus 2, minus 3. Here is minus 1 power 3. Actually minus 1 power 3 is minus 1. 1, 2, 3. Here we have x cube over 64 plus 1. 2 cancelled out, 3 cancelled out, 2 cancelled out. And we are left with 1 over 8, 1 plus x over 4, plus x square over 16, minus minus plus, minus minus plus, plus x cube over 64 plus so on. So dear students, you can take 1 over 8 inside and multiply every term by 1 over 8 and you can get your answer. I hope that you understood this question. After that we have part number 7 and 8, and I am taking part number 8. Part number 8. Part number 8. 1 plus 2x under root. Over 1 plus x. Or rather this is 1 minus x. 1 minus x. You can write down 1 plus 2x power 1 over 2. 1 plus 2x power 1 over 2. And you can bring 1 minus x up, it will be 1 minus x power minus 1. Now you have to open your these two binomial series up to 4th term. We have 1 plus nx, 1 plus n nx plus n into n minus 1 over 1 into 2 x square, n into n minus 1, n minus 2 over 1, 2, 3 into x cube plus so on. And after that we will open up this one also. 1 plus nx plus n into n minus 1 over 1 into 2 x square plus n into n minus 1 and minus 2 over 1, 2, 3 minus x cube plus so on. Here is 1 plus x plus half minus half over 2 into 4x square plus half minus half minus 2 to the 4 minus 3 over 2 over 1, 2, 3 8x cube 1 plus x square, 3 cancel, 2 cancel. Because of this power, odd power, minus will remain as it is. Minus plus, up to so on. So dear students, we can have 1 plus x minus, it will be minus 1 over 8 4x square. 2 to the 4 to the 8, it will come down. Here is minus plus, 3 cancelled out, 2 to the 4 to the 8 to the 16, 8x cube over 16 plus so on. 1 plus x square plus x cube plus so on. 1 plus x minus 1 over 2x square plus 1 over 2x cube plus so on. 1 plus x square plus x cube plus so on. Now dear students, after that, after that you have to multiply them. But remember, in the fourth term, up to fourth term, x cube is involved. If we multiply them and it is greater than x cube, then those terms will be neglected. We will leave these terms. Here we can have we have, take 1 and multiply with all. Here is 1 plus x square plus x cube. Then take this x. It will be x plus x square plus x cube. X plus x square plus x cube. Plus so on. Because next term I have left these terms. Greater than power x3, we will neglect that. This was multiplied by this one, x square x cube, this was left because it was becoming x power 4. Now we take this one, minus 1 over 2x square, minus 1 over 2x square, minus 1 over 2x square multiplying by 1. Then minus 1 over 2x cube. Yes, minus 1 over 2x cube. And after that, all terms will have more than x power 3 power. So that's why we leave them. This term is multiplied by 1 plus 1 over 2 x cube plus so on. Plus 1 over 2 x cube, this one. Because when you multiply the second term, it becomes x4 and they are cancelled out. Dear students, 1 plus 2x, then plus 2x square, then 2x cube minus 1 over this is 2x cube, but here was half x square. This was half x square. Here is x square plus x square, 2x square minus half x square, and at the end x cube plus x cube is 2x cube plus so on. 1 plus 2x plus 2 to the 4 minus 1 is 3 by 2x square plus 2x cube plus so on. Dear students, actually this is your extension, binomial expansion with the help of binomial series. I hope that you understood this question. After this, we have part number 10. In case of part number 10, you will have first term as 1 and x minus 2x square is second term. Part number 10 is question number 1 plus x minus 2x square whole power, yes, 1 plus x minus 2x square whole power 1 over 2. Dear students, this is first term and this one is second term, like that. 1 plus n, 1, this is 1 plus n x. What about x? X minus 2x square plus n into n minus 1 over 1 into 2 x square. Actually, we have to write down up to fourth term, first term, second and third, and then we will have n into n minus 1, n minus 2, 1, 2, 3, x minus 2x square whole cube plus so on. So dear students, by opening these fractions and after simplifying, you can get your answer. I hope that you can simplify it. And remember that I told you, because of fourth term, your maximum power will be x cube, and all other powers which are greater than x cube, they will be omitted, they will be neglected. So in this way, this is a hint for you that you can open up these fractions, multiply here, open the formula of square and cube, then simplify, multiply, and those terms which are including more than 3 power, neglect them. And you will have only 1, then x square and x cube terms. So in this way you can complete. I hope that you can solve the parts which I left for you with a homework. You can do it and they will not be so difficult. Actually, I have chosen difficult parts. So I hope that you can take help from them. Okay, Allah Hafiz and Assalamu Alaikum wa Rahmatullahi wa Barakatuh.